Hello everyone. So today we will solve the problem B of the contest Codeforces round 1095, and the problem goes by the name Everything Everywhere. It is a great problem and the solution which I will provide to you is also great. So let's read the problem statement first, and after that I will move to the solution as well. So what is the problem statement? An array is called good if the difference between the maximum and the minimum value in the array is equal to the greatest common divisor of all the elements in the array. Note that the empty array is considered to be not good. More formally, you are given an array. It is good only if these conditions, which have been written in mathematical terms, like if you have just read this thing, and this is the mathematical term of that very thing, right? So you are given a permutation of p of length n. You need to determine the number of good subarrays in the given permutation, right? So let's understand the problem statement first. So the problem says you are given an array, right? What you need to do, you need to find the number of subarrays, right, such that the maximum of that subarray minus the minimum of that subarray is equal to the GCD of that subarray, right? So you need to find the total number of subarrays that exist in that way, right? Okay. So I hope the problem which was given to you is clear to you. You're given a permutation of length p. What does permutation mean? If you don't know what is permutation is nothing but array which has all the elements from 1 to n and they are only ones, right? That means 1, 2, 3, 4, 5, 6, 7, 8, anything, right? All the values are from 1 to 8 and 1, 2, 2 or rather 1, 3, these are not a permutation, right? And why isn't it? Because 2 has repeated, there is no 2 in this, so this is not a permutation, right? I hope the problem statement is clear to you. I think GCD shouldn't be explained. Just kidding. GCD of any number is what? Let's understand that as well. Let's say I had 4 and 6. So GCD is greatest common divisor, right? So which number divides, which is the largest number that would divide both 4 and 6? That is 2. Similarly, you can find it for multiple elements. Let's say 4, 6 and 12. What is the largest number that divides it? 2. Again, right? Let's say 4, 8 and 32. What is the largest number that divides all three of them? The GCD will be 4, right? You can play around with it, but GCD is, I hope, clear to you, right? All right. So let's read the time constraints of the problem. The problem says that n can be till 2e5 and you will be given n integers p1, p2, pn. The permutation p, it is a guarantee that p is the permutation, right? Let's look at a test case so that we can understand. Let's take 1, 2, 3, 4 and see what are the valid permutations of it, right? So 1, 2, 3, 4, right? Let's say if you took 1, 2, right? So what will be the answer for it? What is the maximum? Maximum is 2, minimum is 1, and GCD of 2, 1 is 1, right? GCD is 1. So maximum minus minimum is 1 as well. So yeah, this is the correct answer. So we do a +1, right? Let's look at 2, 3 as well. So maximum is 3, minimum is 2, and GCD of 2, 3 is also 1. The difference is also 1. So answer is again +1. Let's do that same thing for 3, 4. Max is 4, min is 3, GCD is 1, and the difference is 1 as well. So again a +1. So the number of possible answer for this case was 3 in this particular case. You can play around, take other subarrays as well. Like let's take for your example 1, 2, 3. So 1, 2, 3 in this subarray. In this subarray, the maximum is 3, the minimum is 1. If you find the GCD of all the elements, its GCD is 1, right? And max minus minimum is 2, sorry. So 2 is not equal to 1, so you won't increase your answer in this case. Right? You can play around all the possible subarrays which can be there. You won't find anything better than anything more. So the answer is 3 for this test case. right? You can try for this subarray as well. I don't think it makes a sense to that I sit and prove to you that why the answer is 0. I will prove why the answer is 0 in mathematical terms, not in this term, right? So like I won't be going through the test cases and saying like, okay, this answer is this and this. That's not the case. Now let's say if the length was 1, right? Let's talk about the lengths first, then we will move forward, right? So what if I'm saying if find the subarray of length 1, right? If the length is 1, the maximum will be the element itself, let's call it x. The minimum will be the element itself, and the GCD will be, you can't, I don't think you can find GCD of any number, but let's say like you want just GCD of 6. What will be it? There is no other parameter, right? So x will be, as of now, let's call it x, right? So maximum minus minimum will give you a value 0, and this is not equal to x, right? So in that case, length equal to 1 fails, means you don't get an answer for that, right? Let's discuss about length equal to 2, right? What does length equal to 2 mean? Length equal to 2 means a subarray of length 2, x comma y, right? All the subarrays of length 2, y comma z is a length 2 subarray. A z comma a is length 2, it is another subarray. So what if I had a length 2? Can you find the number of subarrays whose length is 2 and check if it is a valid or not? What is valid? Valid is the condition that they have given to us, right? So yes, we can find it in view of 1 itself, right? Like means we can traverse on all the elements, so that will be big of n, and for every element we will take just big of 1, so ultimately it is big of n, right? How can we do that? We can take the consecutive elements, right? You can take x and y and simply find the maximum out of it, minimum out of it, GCD of both of these, and check the condition. Similarly, you can do it for z comma y, right? Similarly, a comma z, so on and so forth, right? So I hope this thing can be done easily, right? Okay, what happens if you had a length 3? Now things become interesting, right? Let's say if your GCD is, first let's talk about it, right? I'm just talking about it, I'm not throwing anything on you. So if you have any doubt, you, I think being patient with me will be a better option, right? Okay, give me a second, right? All right, so let's say I had a GCD equal to 1, right? Now what I'm trying to say is, what would happen if my GCD was 1? GCD being 1 tells me that 3 elements have a GCD 1, let's say. Then it could be, let's take a small case so that you can understand. Let's say 5, 6, 7, right? This is the closest you can have, right? Means you can't have anything more closer to this, because this is a permutation, right? So this is the closest that you can get. And if GCD is equal to 1, then max minus min is always 2, means you can't have anything smaller than 2 in any case, right? The difference, what I'm saying is, the difference can be at least, means minimum to minimum, कम से कम तो 2 होएगा ही. You can't have a value smaller than 2. Try out all the cases, think of it, don't try, think of it. If the length is 3, it is a permutation. How can you create a length or difference of less than 2? To create a difference of less than 2, you need to have consecutive same elements, right? Means if you had 5, 6, 6, then you could create a difference of 1. But that's not the case, because it's a permutation. So see how things got connected easily, right? Okay, so if GCD is equal to 1, then that can't be possible, right? Okay, now if 1 is not possible, let's take a generic thing, right? Let's take a generic thing and see how everything goes, right? Let's say my GCD val is let's call it k, right? My maximum is, let's say, d, right? And my minimum not D. Let's say for our understanding, let's make the things easier so that we can understand. See, if GCD is not 1, right? Let me write it. If GCD is not 1, that means, what does that mean? That means we can, we will have, not we can, right? We will have divisors of elements, right? What does this mean? Divisors of subarray, right? Divisor of subarray, right? Now, what does this mean? Let's say the first element was x. So the second element will be 2x, third element will be 3x. Then only the GCD will be something greater than 1, right? Because these things needs to be a multiple of something, right? Even if it was 2, let's say, then it should be at least 4. This should be at least 6, right? Otherwise you can't have a GCD greater than less. If you don't have these, then you won't have a GCD greater than 1, right? So if your GCD is greater than 1, right, then the maximum means whatever the GCD is, the maximum value that you will get is 3x, right? Am I making sense to you? I hope so, right? And the minimum value that you will have is x, right? Now think of this. The maximum is 3x. The minimum is only x. So there, and our GCD will be x in this case, right? And if you try to find out a difference, find difference, what is the difference between max minus min? It is 2x. So difference can. Hey, sorry for jumping in. As I was creating a video section, I thought that this might be your doubt that why are we taking the number x, 2x and 3x? All numbers are consecutive, whereas 4, 6, 8 are not in this form, right? So let me quickly give you a hint of how this will work, right? In the further video, I have explained, generally for these terms, like if you had x, 2x and 3x. Let me quickly discuss about what if the numbers are not of a same range, right? Like 4, 8, 12 is what I thought about, but this might also be a case, right? 4, 6, 8, and let's look at it, right? So let's look at the mathematical proof for it, right? Let's say the first number is k, then it is l, and then let's say it's m, right? Now I am saying that GCD, don't think of this as number. Like, let's say I'm saying GCD is D, right? Now, if I am saying so, then I can say that this number will be divided by D. This will also be divided by D, and this will also divide by D. Getting it? Now, if this happens, then this means that I can represent this number as D into A, right? Let's say I can represent this as D into B, and let's say I can represent it into D into C, right? And if D is common in everything and the number is, let's say, increasing, right? M is the largest, K is the smallest, then A will be less than B and will be less than C. Am I making point to you, right? So wait a second, let me reset the canvas for a second. Yeah. What I was saying is, let's say I had K, L, M, and I had and D was my divisor, so I can represent this as D into A, D into B, and D into C, right? And A was less than B was less than C. This condition till this point I hope makes sense to you. Now think of it, right? If this I am saying C is less than A, right? Then the number should be at least the smallest that you can do is 1, 2, 3, right? And C minus A is still greater than 1, right? Means C minus A is equal to 2, right? So the smallest number that you can, like, the smallest difference that you can have, right, is 2, right? Now this might make sense to you that why can't we have a 3 pair and a GCD and a GCD equal to GCD greater than equal to 1 and the condition also holds true for us, right? Like the maximum minus minimum thing still hold. It won't hold, right? Because C minus A, the smallest difference that you can have is 2, right? Means C minus A, right? And after this means it is 2, and after this it is getting multiplied by D, right? D is getting multiplied, right? Let me like show you how things were working. So the smallest number, the largest number was D into C, right? Minus, like it is the full proof, right? As I said you know that this might not happen, see the proof for it as well. So D into C, the largest number, into minus D into A, right? What I'm saying is this should be equal to D, right? Now what I'm saying is let's take D common, it will become C minus A, which is equal to D. Now C minus A should be equal to 1. Tell me one thing, is it possible to make C minus A equal to 1? No, you saw the minimum value that we can have for C minus A was minimum, not, right? And it is saying have any
for
value
our
of C
understanding,
minus A which is equal to 1.
let's make the
No, it
things
will
easier so
always
that
fail,
we can understand.
right?
See,
So that is the
if
reason you won't have a
GCD is not
equal
1,
to
right?
GCD
Let me write
and
it.
maximum
If
thing for length
GCD
equal to 3.
is
I hope I make
not
sense.
1,
Continue for
that
the further
means,
video.
what does that mean? That means we can, we will have, not we can, right? We will have divisors of elements, right? What does this mean? Divisors of subarray, right? Divisor of subarray, right? Now what does this mean? Let's say the first element was x, so the second element will be 2x, third element will be 3x, then only the GCD will be something greater than 1, right? Because these things needs to be a multiple of something, right? Even if it was 2, let's say, then it should be at least 4, this should be at least 6, right? Otherwise you can't have a GCD greater than less. If you don't have these, then you won't have a GCD greater than 1, right? So if your GCD is greater than 1, right, then the maximum means whatever the GCD is, the maximum value that you will get is 3x, right? Am I making sense to you? I hope so, right? And the minimum value that you will have is x, right? Now think of this, the maximum is 3x, the minimum is only x. So there, and our GCD will be x in this case, right? And if you try to find out a difference, find difference, what is the difference between max minus min? It is 2x. So difference can never be less than 2x in any case, right? And this is a proof, right? This is a proof that if you had a dx, or rather, really sorry for it, if you had x, you had 2x, you had 3x, right, of length 3, then the minimum thing, like minimum value can be 2 only, right? You can't have anything smaller than 2. Let's say 4, 6, 8. See, the GCD is 2, right? So even if you're trying for GCD equal to 2, you will fail. You will fail. Why will you fail? Because the difference is 4, right? Difference is 4. If the difference is 4 and your GCD is 2, how will you make up for it, right? But again, let's why not increase the number? 4, 8, 12. See, if you increase the number, the difference among these two values also increase. And it has a proof, right? This is a proof that I am giving. If it is x, it is 2x, it is 3x, the worst you can do that the difference will be at least 2x, right? And the GCD will be only x, right? Are you getting this point? That how are we connecting, right? If the value is x, second value to be a to get a GCD of, let's say, x, second value should be x, 2x, third value should be 3x, right? And the difference will become 2x ultimately, right? You won't be able to create a smaller architect for this. I hope I am making sense to you, right? The mathematical proof is this. These are the mathematical proofs for this, right? Now you understood that length equal to 3 is not possible. So is there any sense of checking that the length of 4 is possible or not? It won't be possible, right? It's very obvious, right? Because the difference will increase. X minus, sorry, 4x minus x. The values keep on increasing, right? So you will reach, you have reached the threshold at length equal to 2 only, right? You won't be checking for the length equal to 3 also, right? So this is the problem statement, right? So the problem ultimately boils down to the finding the length 2. Now length 2 means checking consecutive elements, right? You just need to check if consecutive elements hold that condition or not. And why, like, I hope the proof is making sense to you, right? So the problem statement, now the solution becomes very clear, right? Let's quickly look into the solution. We are taking the vector, right? And what we are trying to do, we are creating an answer, right? Difference is abstract difference between the consecutive elements, right? Why, what is this? Like, let's say you had consecutive elements at 4 6 comma 4, right? The abstract difference is 2, right? And GCD is 2 as well. So you will do a answer plus plus. So you do a difference, you find the GCD value. If difference is equal to GCD value, you do answer plus plus, and finally return the answer, right? It gets accepted. I hope the solution was clear to you. If you look at the time complexity of this problem, it is big of n only, right? So I hope it was helpful for you. If it was, then do please give a like, do subscribe as well. And we are thinking of creating a Discord server, so I'm on it. Like, I will be adding description links to it as well. So if you are interested, you can definitely join. I have not created it as of now, and but if you want, I will definitely create, because one of my subscribers had suggested me. So we'll work on it. So thanks for watching, and please do subscribe. It gives a lot of motivation. Thanks for watching.